Okay guys, today on page 131 we have the next question that give us 4 points. Those 4 points represent a rhombus. It's not a bus that brings people from the Rome city, no. It's a figure that has certain properties. So here is important that you remember the properties of a rhombus. If you do not remember at all, simple, use your web browser and Google it. Search. When you find that, you're gonna actually you should find this information, okay? And the most important thing that you need to remember, if I look here the graph and that's all the properties that are pointed here. It's important that a rhombus, all the sides are equal. Okay, no matter what is the value, all of them should be equal. And the most important one is the diagonals form 90 degrees, so they are perpendicular. Okay, so you know with the slopes what's gonna happen. And the other thing about rhombus is opposite angle, okay, they are equal. So here we have an angle alpha and the opposite angle is alpha, so that's why they're equal. Same thing here for B. Okay, so that's the most important thing about rhombus, the properties. And now that you know this, you're ready to go. So the first question says use the distance formula to show ABC is a rhombus. So why do I need to do this? Because we already know that all the sides need to be equal. So remembering the distance of the formula distance, I know D is equal. You know this by heart, but still I'm gonna redo it. Okay, so how many sides do we need to find? We need to find 4 sides. So we're gonna identify those 4 sides, AB, B, C, C, D, and DA, but using the proper notation, we should write AD. So let's do the first one, and then we're gonna assume it's a rhombus. So of course my square root, I decide what are the points, so I'm gonna do AB, so I write A 3 4, I'm running out of ink there, B 8 4. Again, same method than before, x, y, 1 and 2. Okay, so now x2, so I go here, x2, that's 8, simple, minus x1, 3, perfect. Okay, I'm doing all the steps just in case. There you go. y2 and y1 are the same, so I know that's going to be 0 right away. Okay, 4 minus 4, 0, there's nothing to do here, super simple. And so 8 minus 3, that's 5, 5 squared is 25, and we ended up that my answer is 5. Okay, so in this problem I should continue and solve for B and BC, CD and AD, and I'm gonna find that all the sides are equal to 5. So that's gonna be your homework. That's what you have to do. Okay. Now we're gonna go and solve B, and B says use midpoints to verify that its diagonals bisect each other. Okay, so first let's remember that this is the shape of a rhombus. Okay, I'm doing the line, and we need to find out if this diagonal bisect the other one. So here the concept is the concept that I'm looking for is bisect. Bisect means that it cut the line in two parts that are equal. Okay? So if there are two parts that are equal, that means that this point here is my midpoint. So if they bisect both lines, so that means that they have the same midpoint. So that's at the end what I'm looking. I'm looking to find the midpoint of this diagonal and find out if it matches with the midpoint of the other diagonal. And if it is that true, yeah, we have a rhombus. Okay, let's check out. So I'm gonna assign the vertices a letter A, B, C, and D. Okay, and my diagonals are AC and BD. So now let's find out the midpoint of each one of those diagonals. So the midpoint formula, if I remember, is x1 plus x2 over 2 for the x coordinate, and y1 plus y2 over 2 for the y coordinate. I'm gonna find first the midpoint for AC. Okay, so I'm gonna decide that my A is gonna be my first point and C my second. Okay, so I know this is x, y, x, y. Let's go, let's do it. So I just replace the value of x of each one, so 3 plus 5, that's 8 over 2. 8 over 2, I'm gonna write here all the steps. Okay, then y, it's 4 plus 0 over 2, very simple. So don't forget to simplify, that is 4 and 2. So this is the coordinate of my midpoint of the diagonal AC. So using the concept that we just learned, my midpoint of the diagonal BD should be the same. It should be 4 and 2. If it's not, this is not a rhombus. So let's check out. So x1, here we have B and D, that's 8. 8 over 2. Oh, look at that, the same. So 8 over 2, yeah, that's 4, fantastic. Let's see if the y coordinate is the same. So 4 plus 0, that's 4. 4 over 2 is 2. Yeah, great. We just verify that they bisect. Let's continue with the question C. The question C says, use the gradient to verify that its diagonal are right angle. So, very simple. The problem is asking us to find the slope or the gradient of each of the diagonal. The formula for the slope or gradient is y2 minus y1 over x2 minus x1. So, very simple. we're gonna find both slope, but how are we gonna verify that the diagonals are right angled? It's simple. If we remember the concepts of perpendicular between slopes, one of the slope should be the negative reciprocal. So let's find out first that what is the slope for AC. So AC, I'm going to write here my point A, that is 3, 4. Okay, we're going to go classic method and 5, 0. X, Y, and 1, 2. So the slope of AC is going to be equal to y2, so I go y and 2, that's 0, minus y1, y1 that's 4, over x2, that's 5, and minus x1, that is 3. So here my slope is negative 4 over 2. I simplify. Always check that you have the simplest answer, and here I can simplify so that become a negative 2. So the slope that is perpendicular to AC should be equal. So when I'm going to try to find if the slope of BD is equal to the reciprocal and negative. So the negative reciprocal, that's 1 over negative 2, that's the reciprocal. Okay, negative negative, rule of the sign, this become 1 over 2. So if I find that the slope of BD is equal to 1 over 2 using the concepts, I can say that I will just verify that the diagonals are at right angle. Now I'm going to go again with the same step, classic. I'm going to write the points BD, the coordinate for B is 8, 4. The coordinate for D is 0, 0. Okay. This time I'm gonna choose perfect. That's 1 and 2. Here the slope is going to be very easy to find because one of the point is 0, 0. Okay, so my y2 is 0 minus 4, so it's negative 4, over x2, that's 0, minus x1, that the minus 8 become here negative 8. Rule of the signs become positive, and it's I do all the steps positive, and I can simplify this, and this is 1 over 2. And now I can say yes, the diagonals are at right angle. And for the question D, on a grid paper, okay, illustrate A, B, and C. Very simple, and that's what you can do at home. Thank you.